If you live in North America and you think that the countryside has the cleanest air, well, I think that this video is about to shock you.
A team of researchers from the University of Colorado discovers, for the first time in North American history, the presence of toxic chemicals at pollution levels that no one knew existed until today.
When they outlawed these
All they
toxins,
wanted to
they
do
simply
was study
said,
how
You see, no one really travels to Oklahoma to look for polluted air. I've heard of a few people who go there looking for stormy air, but definitely not polluted air. On the contrary, because of the conditions in Oklahoma, the region is perceived so strongly as a clean laboratory that it hosts a site called the Guest Instrumentation Facility of the Atmospheric Radiation Measurement in Lamont, in Oklahoma. It is located there because the area is very flat and has been considered until now a place with very little local pollution. The population around the site is of less than 50,000 people within 100-kilometer radius. And indeed, between April 28 and May 31, 2023, a group of researchers from the University of Colorado decided to set up there to investigate a topic much less dramatic than what they actually discovered, the point where gas turns into matter. The process is called NPF, which is new particle formation. They wanted to understand how particles form within the layer directly adjacent to the ground, known as the boundary layer gradients. As we all know, the air around us is full of invisible gas molecules. Under certain conditions of humidity and solar radiation, these molecules begin to collide and stick to one another. They form small clusters, then large clusters, until they become a solid particle, what science calls an aerosol. Without this process, there would be no clouds and there would be no rain, basically.
Right, guys, stop for a second. These videos are taking me a lot of time to create. In each video, I need to make sure that I understand every small part of the story and I'm not giving you false information. And then I have to film stuff and then I need to edit it all out. And at the end, I really try to make sure that you'll enjoy the video. So if you like my videos and appreciate my work, please like the video, subscribe, and comment down below what would you like to see in my next episode. So now, think of the atmosphere for a second as a layered cake. The very bottom layer, the one touching the ground where we live, breathe, and fly, is called the boundary layer. Our friends wanted to investigate more deeply how the aerosols form within this layer. So to do this, they used an advanced measurement system that's called NO3 SIMS. It's like a super sensitive electronic nose. Of course, who doesn't know what that is? This device sucks in outside air at a constant rate. Inside, that air meets nitrate ions. These ions stick to the molecules in the sampled air and give them an electric charge. Now that the molecules are charged, they can be controlled. The device passes them through a series of electric and magnetic fields using a vacuum. Light and simple molecules like oxygen and nitrogen fly through the device at enormous speeds. Heavy molecules, on the other hand, move slowly. The device is able to weigh them, and so allowing it to identify exactly which molecule was caught in the net.
So Daniel Katz and his colleagues continue working while the device samples the air every second and the data begins flowing into the computers. I remind you again, the researchers weren't looking for industrial pollution, but then among the thousands of signals and lines in the screen, something unexpected popped up. It was heavy, slow, and cumbersome molecules. The researchers noticed strange and unexpected chemical fingerprints. The team essentially discovered, in the skies of North America for the first time in history, accumulating and nearly eternal ghost toxins. These are invisible particles hazardous to health, and pay attention, they are nearly impossible to break down. We will talk about it more later on. And more than that, as the researchers continued to look for data, they discovered something even stranger. This chemical breathes. On May 6, as the Oklahoma sun rose and temperatures soared to 34 degrees, they saw a massive spike in the concentration of these toxins on the screen. But then at night, when it turned cool again, those signals weakened significantly, as if the substances were going back into hiding somewhere. Meaning the hotter it gets, the soil and the particles around them release these toxins into the air. And the opposite way around. At night, when it's cool, the signals fade. This behavior points to the possibility of permanent air pollution, and at this stage, the researchers begin to realize that this isn't just some random localized pollution bubble like the sheep farts in New Zealand. From here, the entire study takes a new turn. What started as an attempt to understand how particles are born in the air turned by accident into the discovery of a hidden circle of pollution in the heart of the US. The results are in. The researchers have finished their analysis, and now we can finally call the problem by its name. Meet MCCPs, which stands for medium chain chlorinated paraffins. Industry has been using MCCPs for decades as lubricants for giant metal cutting machines, or to make the plastic in our toys and clothes more flexible, or even as flame retardants in our carpets and car upholstery. But how does a substance used to lubricate machines inside a closed factory reach the open air in the middle of a field? The answer is the sewage system. Allow me a quick explanation of the sewage system. Every time we flush the toilet or a factory washes its production floor, that water doesn't just disappear, it becomes wastewater. The municipal system pipes it all to wastewater treatment plants. Over there, technology and chemical biological treatments manage to separate the water from the solids. And then in some countries, the treated water goes toward irrigation or streams, but what remains is the sludge, meaning biosolids, a thick mud rich in organic matter, nitrogen, and phosphorus. It sounds amazing on paper. We take human waste and turn it into organic agriculture fertilizer. It's cheap for the farmers, it saves the state from having to bury the waste in landfills, and it returns nutrients to the soil. But there's a catch. Our treatment plants were designed to filter bacteria and break down simple organic matter. They weren't exactly designed to handle resilient molecules like the ones identified by the researchers. These chemicals stick to the solid sludge. When the trucks leave the treatment plant and dump that sludge onto the fields of Oklahoma, they are essentially spreading massive concentrations of pollutants directly onto the soil that grows our food. From this point on, the process the researchers uncovered begins: volatilization. As soon as the sun hits the field and the temperature rises, the molecules trapped inside the fertilizers start to move. They don't stay in the soil, they actually break free, and then they turn into gas and rise. And because they are heavy and some other reasons, they don't fly off into space. They get stuck here with us, like your aunt who comes over for a few days and just never leaves. Okay, why is this discovery so alarming? Because MCCP is sort of this accumulative poison. When the molecule enters our body, and if it's in the air, it enters easily with every breath, it takes a very long time to leave. It is also hydrophobic, meaning it fears water and seeks out fatty areas. In the human body, those areas are our tissues, our brain, our liver, and our kidneys. Our bodies are not equipped with the enzymes that can break the strong bond between carbon and chlorine. As a result, the substance simply settles in to our cells, and you can imagine how harmful that is. Due to this durability, they are defined as persistent organic pollutants, POPs. And I have one disturbing question. Why are we only finding out about this now? After all, flame retardants and plastic toys aren't new inventions, and nothing new happened in this regard in Oklahoma. In 2009, after years of struggle and thanks in part to the decisive 2009 EPA report, which is a crucial economic environmental study, a decision was made to outlaw SCCPs, which is short-chain chlorinated paraffins. This decision eventually led in 2017 to the inclusion of SCCPs in the Stockholm Convention as prohibited substances worldwide. The report and further studies managed to show that the SCCPs are too toxic and too dangerous. It was supposed to be a moment of real change, but what the public didn't know was that alongside the restrictions of the SCCPs, the industry simply switched to using nearly identical compounds, the MCCPs. The main difference between them is simply the length of their carbon chain. SCCPs contain chains of 10 to 13 carbon atoms. MCCP contains longer chains of 14 to 17 carbon atoms. That's it. That's the whole difference. And so the widespread use of MCCP was born. You're probably wondering, is MCCP at least less harmful than the substance banned in 2009? The scientists' answer is not really. Because its chain is slightly longer, it actually tends to cling even more strongly to fatty tissues. Potentially, it will stay in the body even longer. But legally speaking, it's a new substance, even though chemically, it's almost the same thing. And I lately learned that this is called a regrettable substitution, which means the replacement of a toxic chemical with another chemical that provides a similar function but often used to bypass specific regulations. So this is a massive loophole in the law, right? The regulator bans a specific substance by its name, and then the industry simply modifies one end of it and continues selling it under a different name. For 15 years, MCCP was considered a legitimate substitute, and because of this, research on it was partial, and so no one really tested it in the open air until Daniel and his colleagues' study was revealed. In short, it's a regulatory bluff that is just costing us our health. Let's go back to our researchers. They compared the concentrations of the MCCPs found in Oklahoma to data from other parts of the world, and they published this comparison in their study. The average concentration observed in Oklahoma stands at approximately 3,100 picograms per meter. That's picograms, a tiny microscopic amount of substance for every cubic meter of air. Does that sound like a little? Picograms sounds almost cute. But no, this concentration is similar to the levels measured in several places in China, such as Beijing. Not so cute anymore. This is a deeply concerning comparison because China, in case you didn't know, is currently the world's primary producer of MCCPs. So the Chinese might be okay with these numbers, or at least not surprised by them, because they are packed with factories. But Oklahoma, Lemont, a place without a single factory of this kind within a 100-kilometer radius, a place full of beautiful green fields sharing the same pollution levels as industrial cities in China? But the numbers do not lie. These figures expose the scale of the illusion we think we live in. We think that if we are far from the city, we are protected, but that's not really the case. You see, this study supports the realization that there is no longer a bubble of clean air. If concentrations in rural Oklahoma are similar to those in China, it means that pollution has become something global. So what do we do with this disturbing information? Usually when people make environmental videos, it ends up with this conclusion that you need to switch to drinking through a cardboard straw for the rest of your life.
Oh, brother, this guy stinks!
An experience that always ends with you sucking a drink through a soggy paper rag. I'm not sure The solution lies with the individual. Perhaps instead of the regulator chasing every chemical separately, a never-ending game of cat and mouse, we could move to a system of class-based regulation. For example, if one substance in the paraffin family is proven to be life-threatening, the use of the entire family should be prohibited or at least conditioned on in-depth research. Maybe the answer is investing in advanced wastewater treatment technologies. It might be expensive, but perhaps less expensive than treating the diseases that could potentially be caused by MCCPs. I don't know. Regardless, this new study makes it crystal clear. For the first time in North American history, there are MCCPs in the air. And now that you know what they are, I hope that it doesn't remain just as an interesting discovery. Just drink it from the cup. God damn it!